variable length subnet mask, VLSM, or what I've coined subnetting in the real world. This business that we've been having of subnetting with the requirement of hosts or net gives us equal sized subnets, and that one is a bit wasteful because if you have a network, say where you have your HQ, so let's say this is the HQ router, that you have a one connection to a branch and another branch, let's say 3 branches. So you have branch 1, branch 2, branch 3. Yeah, the business that we have seen in the previous 3 videos is you subnet, like in this case you'd require how many networks? 1, 2, 3, 4, 5, 6, 7. So if you are to subnet with the requirement of networks, this way would say that you need 7 networks. So that you do your 2 to power what will give me 7 networks. So when you do that, you'll get 7 equal sized subnets. Yeah, so you see, let's say that the ranges of those subnets is 40 computers, let's say. So you see, this is what we call this here, yeah, the one links, one as in wide area network links, because that's a network on its own. Yeah, you're giving it here, you'll only use 2 usable IP address, yeah, one here and another one here. The rest 38 are wasted. You cannot use them anywhere else, and it's not like you're gonna have computers in that link, because so there is no way you can have computers between there, because you see the HQ here could be Nairobi, and maybe this is a branch in Kisumu. So first of all, this whole thing is the service provider network. You cannot have computers there, so you'll have wasted your IP addresses. So Vlsm is where we tailor every subnet. Yeah, every subnet, like in this case, we tailor it to the requirement. That way we don't waste IP addresses. But I think, of course, you'll appreciate what I'm talking about when you see how we go about it. So Vlsm, you always start with the highest network requirement. I mean, with the highest host requirement, because when you know how to subnet with the requirement of hosts, that's what you have looked at in the previous video, you can be able to subnet with the requirement of that is, you can be able to subnet, you can be able to do Vlsm, basically. That's what I'm getting at. So let's start with the highest host requirement, which you can see is this one here, 100 hosts. Yeah, so let me go to my whiteboard. So we have 20.0.0.0 slash was it slash what? The given root is a slash 16. So slash 16. So we start as if we're just subnetting for 100 hosts. So in this case, we just that's meant to be host. So we just say 2, using my 3 steps, 2 to power what will give me 100. But remember, for the hosts you have to minus 2. So you might say 2 to power what will give me at least 1 or 2, because I have to minus 2 unusable. So we can actually go with 1 or 2. So this is where now we need to write our whatever, 1, 2, 4, 8, 16, 32, 64, 128. Yeah, so for us to get 102, you can see that of course this is 2 to power 0, 1, 2, 3, 4, 5, 6, 7. So in this case 2 to power 7 is what will give us 128. So we'll have at least met the 102 requirement. So we then convert this into binary, that is 16/16 into binary. So we have 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8, that's 16. Then we have 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So now we have determined that we need at least 7 host bits if we are to address this guy's requirement. So with hosts, I said you count from right to left. So you have 1 2 3 4 5 6 7 7, yeah. So this becomes a 1, and all these are now ones. They are borrowed or masked. So now if you convert this back to decimal, you'll have 255.255.255. So this one is that whole thing there, dot, this would be 128. Yeah, because you can see if you list my whatever here of 1 2 4 8 16 32 64 128. So and 128 here now will be our increment. Yeah, so first of all we have created how many networks? We say 2 to power network bits, and those are the bits that we have added. So we have added 8 ones 9, so 2 to power 9, which will give us 512, I think. Yeah, 512 subnets. Sorry, this is supposed to be 512, not 515. It's 512 subnets. So each subnet will have 2 to power 7 computers, which is 128, but you have to minus 2. So the usable IP addresses is 126. So you can have 126 computers in that LAN. These guys only have 100 computers, but they have 26 unused addresses that they can use for future growth. So now we need to list those subnets, the 512 subnets. We'll not list all of them, of course. So our increment is 128 and is happening at the 3rd octet. Yeah, so we have the first subnet will be 20.0.0.0 slash, but now is a slash 25, right? Because yeah, so it was 8 16 24, and now this is 25, so it's a slash 25. Our increment is 128 and is happening in the 4th octet. So we'll have 20.0.0.128 slash 25. If you add 128 to 128, you'll have 256. You cannot have 256, so that becomes a 0, and this one now becomes 20.0 dot slash 25. We have 20.0 dot 1.128. If you add 128 again, it will be 0, then you have 2, yeah, dot 020. all of these are /25 going down until you have the 512th network. Yeah, the last network will be the last network will be 20.0.255.128/25. So that will be the last subnet, the last of those 512 subnets. Yeah, of course, how I've gotten there is if you add 128 here, it will be 256, meaning that that will be a 0, right? You carry 1. If you add it there, it will be a 256, meaning that that becomes 0. Then this becomes 1 and 20. So that cannot be part of this subnet, because you see these guys, they had bought their block or prefix length was 20.0/16. So there's no way you can have 20.1, because 20.1, 20.2 and all that is sold to a different client, maybe, yeah, from the ISP perspective. Okay, so that's not there. Now with Vlsm, you just take like the first now to cater for the first requirement. Yeah, now this probably could be the same, like the same network that we had. So let's say this is where you have the HQ that have 100 employees, so with 100 computers in that. So the 20.0.0.0/25 will cater for those guys. So for the other branches, this could be a network that looks like this. So this is where you have maybe branch 1 is a bigger branch, they have 50 employees there. Now the next branch, maybe they have 20, and maybe this is the last branch that they opened, they have only 10 employees in that small branch. For the 2 hosts, it could be 2 here, 2 here, 2 here, yeah, because as in 2 IP addresses, you assign 1 here and assign 1 here, because you see, for the branch and the HQ to communicate, these 2 routers must first communicate with each other, so they'll need to have IP addresses. So we have catered for that. Now with Vlsm, essentially is what we call subnetting a subnet. Yeah, so what we need to do is come here, so, and this is where you need your spreadsheet to note the subnets that you have used. So like this one, we know that it is used, so we need to take this other one here and resubnet it again for 50 hosts. And so we have taken that second subnet, and so we start afresh as if this is where we started. So we'll say 2 to power what will give me 50, but for hosts I said you should do like 52. Yeah, because you know that for you to have 50, you need to have at least 2 more because of that minusing. So with our handy binary chart over here, we can see that in this case our x have to be 6, because 2 to power 5 would give us 32, which is way short than the 50 hosts that these guys need. So from there we now write this subnet mask in binary. So this is where you have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8 dot 1. 1 2 3 4 5 6 7. Yeah, that's the /25 now in binary. So we count 6 host bits. So we have 1 2 3 4 5 6 1. So by doing that, we'll create 2 to power 1. So 2 to power 1 subnets, which is 2 subnets. So each capable of having, each capable of having 64 hosts, but you have to minus, because these are the 6. So 2 to power 6 will give us 64 hosts, but you have to minus 2, so that you have 62 usable IP addresses. So our increment, of course, is 64, because this is where we have 128, 64, 32, 16, yeah, 16, 8, 4, 2, 1. So if you're to match, of course, you can see that our last one falls under 64. So that's our increment. Now to write those two subnets, this is where you'll have 20.0.0.128/26. Then you have 20.0.0. If you add 64 to 128, that will be 192/26. Yeah. And so this is what I was saying, that a spreadsheet might be handy, because so right now this one here also is gone in our original subnets, but we have two child subnets that have, or the second generation of the subnet that we got. So we can take 128 and cater for this one. So maybe now this is where we'd have 20.0.0.128/26. And you can see where this concept of VLSM, variable length subnet mask, is coming about, because here you have a /25, here you have a /26. Now we have catered for those. We can take the other subnet that's not used, then we subnet afresh. The .128 is gone, so we now subnet afresh for the 192. So we do it with a requirement of 20 hosts. So we say 2 to power what will give us, and here we need to note at least 22, because we have to minus 2. So with our chart there, hey, yeah, I meant 16, 32, 64, 128. So for 22, you see that we'll need 2 to power 5, because that's what will give us 32. So in this case, our x is equal to 5. So /26 is where you have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 1 2 3 4 5 6. So now we count 5 host bits. So we have 1 2 3 4 5. This one becomes a 1. So again we create 2 subnets, which is equal to, now for the hosts, of course, that's where you have 2 to power 5, and that's 32, but you have to minus 2 to get 30 usable IP addresses. Now our increment, of course, is this is the range of our networks. But also if you write our 1 4, and I think I have illustrated this enough. No, I have skipped something. Yes, 2. Yeah, so eventually you'll see that it will match to 32. So that's our increment. and it will be two networks. So the first one will be 20.0.0.192/27. so this other one here will be 20.0.0.192. if you add 32, that will be 412 carry 1 2 224, if I'm not wrong, /27. yeah, so we take this one, so that one now will be gone. We applied 192, so we have 20.0.0.192/27. so we now subnet for 10 hosts. So subnet for 10 hosts, we'll need to take this and subnet it now for 10 hosts, as if we are starting afresh. So 2 to power what will give me 10, but at least 12, because we have to minus 2. So with our chart here of 1 2 4 8 16 32 64 128, yeah, so our x have to be 0 1 2 3 4. Our x have to be 4 for us to get, because 2 to power 3 will give us 8, which is short of the hosts that they require. So we write 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3, that's /27, 1 2 3 4 5. yeah, now we count 1 2 3 4, so that one is borrowed or it is masked. So again, we have created two subnets with 2 to power 4, which will have 16 IP addresses, but we have to minus 2 to get 14 usable IP addresses. So we have met this guy's requirement of 10 hosts plus 4 IP addresses they can use for future growth. So the two networks, the increment, of course, here we can see is 16. So we have, where is that? 224. So the first one is 20.0.0.224/28 now, and the other one is 20.0.0.224 plus 16, that would be 0, 0, you carry 1 3 4, 240/28. So come here, then we have 20.0.0.224/28. You can see how the variable subnet mask is coming about. So we are done with that. So that subnet is gone. We still left with this, so we subnet it for 2 hosts. So we ask ourselves, 2 to power what will give us 2 hosts, but we know we need at least 4, because we have to minus 2, because these are 2 usable IP addresses. So in this case, we can see that our x have to be 2. Yeah, I have to be 2. So Now we write this thing in binary. So we have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4. That's 28. 1 2 3 4. Now we take two host bits, 1 2. These guys, they can be borrowed or they are masked. So now by doing that, we create 2 to power 2 subnets, which is equal to 4 subnets. Now for the hosts, we have 2 to power 2, which is equal to 4, but we have to minus 2, which is equal to 2 IP addresses, and that's our requirement. So now to list the 4 subnets, so this is where you'll have 20.0.0.240/30. If you have to count all these ones now, they are a /30. So you have 20.0.0.244/30, 248, the last one will be plus 4, that will be 12. Yes, 5. 252. If you try to add 4, you'll get 256. So you cannot have a 256. But those are the subnets that we'll have come up with. So we can now come to our network here, and now maybe this is where you'll have your .240, .244, and .248. So we even have reserved one small subnet that is capable of 2 hosts. So maybe this is where you'd have .241 as the first usable IP address and .242 assigned to that router interface. I'm boldening it so that we all can see that interface. So maybe this would be 245, this particular interface here on the router. This other one here would be 246, because 247 is a broadcast. Yeah, on and like that. So the requirement of 2 hosts is usually suited for point-to-point links. So you can see with Vlsm, we have been able to cater for that network using only 2 subnets. Yeah, the original ones that we created, the original of the 512 that we created, we only used 2. Without Vlsm, we would have created 512 subnets. Then we take what we had. Yeah, so we take 1, 2, 3, 4, 5, 6, 7 networks. Yeah, so we would have eaten into 7 of these subnets. Yeah, and you see they had a lot of IP addresses, so we would be wasting. And you can see these things are public IP addresses and they cost money. So that's why I'm saying Vlsm is what is used in the real world out there, because that style of subnetting we have done, it could actually be an ISP style of subnetting, where you work for an ISP, so you need to know how to subnet that so that you can sell the customers what they require. Yeah, so with that, that's all about or that's subnetting in all of its glory. In the next lesson, we're going to look at how we'll do a Vlsm. We subnet an addressing space and configure it on the devices. Now we see how we assign those IP addresses to the routers and all that. So see you in the next video.